We were also again advised to use only low carbon steel because of the ductility reason, and the edge clearances and hole points were a little larger than what 2 times of the hole diameter is the conventional being followed. The unique thing that we were asked to develop was a prefabricated jumper, where they thought that using the conventional conductor as jumper would be very unwieldy. To simplify the design, what we first did was we just used 8 tubes of same cross section for which the conductor was used, and we did 8 tubes because we didn't want to go in new kind of surface gradient calculations for this jumper. But subsequently, although PowerGrid initially thought this design was good, but on greater deliberation, they found that 8 bundle jumper would be very unwieldy to install, and they recommended to us to design it afresh and make it into a twin bundle. And then we did a voltage gradient calculation. We find that if we use 100 diameter twin tubes, it will also have the same ampacity as 8 conductors, 8 Moose conductors will be equal to the ampacity of 2 tubes of 100 diameter, and we also did the voltage gradient calculations as per IEEE guidelines, and we found that the value of voltage gradient was 5.1953 kV per centimeter, which was well within the 30 kV per centimeter generally considered acceptable by IEEE. But PowerGrid in the meantime installed by conventional method the jumpers, but when the next actual construction takes place, they will consider using prefabricated jumpers. So all clamps and connectors used in substation have been by gravity die casting. Major challenge was development of such huge casting dies, for which we required new kind of molding machines, which we were accustomed to using this screw type molding machines so far. We had to work on calculation of effective electrical contact area for gravity die cast substation connectors, which was done to ensure current carrying capacity for all times. These are some examples of the substation connector which were used in the system. One real challenge was to bring an 8 bundle down to twin bus bar. That connection, we had displayed this in Electrama 2012, and we have a display of this in our factory, this particular display was considered very unique by PowerGrid also. And at last the efforts and time put in the project yielded its fruit on 27/12/2012, when the test line of 1200 kV was charged in the presence of all the company delegates and PGCL project steering committee, who took an active part in designing and development of the project. The project may be regarded as a golden project which will change the power transmission sector in the world, across the globe. After installation of this is a post-installation experience. After installation of all transmission and hardware substation, insulator, hardware fitting, clamps and connectors, it was observed that the physical and mechanical properties of the fittings, clamps and connectors are satisfactory. The performance of the product was good, and as per everybody's expectation, there was no discrepancy or any misfit or any compatibility issues for the product with any other product which was used by other members of the work group, as our products were made keeping in view the compatibility with other products as per the specified guidelines very strictly. Major concern in all UHP line is the corona effect, and they are continuously monitoring the corona performance and the voltage gradient performance, and so far there are no alarming signs of any kind whatsoever. This is a picture of switching which was taking place when the director project, Mr. Ayaz, switched on the substation. Our Mr. Agarwal was present there on behalf of Supreme and Company. These are the picture of one of the view of the substation. These are the various fittings supplied by us, which are there in the system marked there. Thank you.